Good morning. Today we are discussing about welding metal joining techniques for a fifth semester students. Welding, today we have covered various welding techniques, definition of welding, classification of welding process, importance of welding as fabrication technique, introduction to welding processes and welding joints, welding positions and welding terms. We are discussing these points in this class. So, metal joining is an important aspect of industrialization. Application of metal joining spread from the household domestic needs to defense needs like shipbuilding and aircraft constructions. Even precise applications like integrated circuits used in almost all electronic industries are made by soldering, one of the metal joining techniques. Not only welding, various metal joining techniques are welding, brazing, soldering, riveting and fastening. Welding is simply the metals adjoining each other and heated to elevated temperature and allowed to solidify it. After welding, the strength will be obtained maximum levels. Brazing, the metals are heated to just above 427 degrees centigrade and allowed to cool. After brazing, the strength values are medium. In soldering, the two base metals are heated to or at the joint heated to just below 427 degrees centigrade and allowed to cool. The strength levels are minimum. And riveting, just adjoining two sheets or two rods by using nut and bolt are riveting. The strength values are minimum. And fastening, two sheets are adjoining each other by using edges or sides. Different close shapes are adjoining to that. The fastening is also strength values are minimum. Apart from that, welding to show higher strength hardness values than other metal joining techniques. So that's why it is used as a tool in industrialization. Welding is a process of joining similar and dissimilar metals by application of heat, with or without application of pressure, with or without addition of filler metal. The main requirement for welding: heat, pressure and flux material. Heat, elevated temperature are needed. Depending upon the source of heat, different welding processes are coming to existence. Pressure needed not only in the plastic welding process, flux material to remove impurities present on the surfaces of the base metal and the filler metal. The filler metal providing the extra metal to the weld by melting the end of the filler rod. The composition of the filler rod should be compatible to the metal being welded. The surface of the pieces must be sufficiently cleaned to permit clean metallic surfaces to come in contact. In some operations, fluxes are applied to the parts being welded to dissolve the oxides or to prevent the formation of oxides. These are different types of fluxes for different metals. for example, ferrous metals like borax and sodium carbonate. Applications of welding used in industries and aircraft, automotive, automobiles, pressure vessels, storage tanks, railroad equipment, piping and pipelining, and shipping. These welding processes are classified fusion type and plastic welding. The fusion type welding process are thermite welding, arc welding, gas welding. The arc welding classified metal arc welding process, atomic hydrogen welding process, and carbon arc welding process. Plastic welding or froze welding or resistance welding. The resistance welding again subdivided into spot welding, butt welding, seam welding, and precision welding. The plastic welding, the pieces are heated to plastic state and forced together by external force. No filler metal is used. Fusion welding, the metals at the joint are heated to molten state and allowed to solidify. The filler metal used depending upon the thickness of the base metal. Important welding processes are gas welding, arc welding. In case of arc welding, tungsten inert gas welding, metal inert gas welding, plasma arc welding process, electron beam welding process, laser beam welding, thermite welding, and resistance welding process. Gas welding is a fusion welding technique. Joins the metals using by heat of combustion, oxygen and acetylene. The intense of heat produced and melts the surface of the metals to be welded, and thereby coalescence is produced. Generally, filler metal is used. So, arc welding is also known as shield arc welding process. It simply defines the welding group of welding processes like electric arc welding, TIG welding, MIG welding, where coalescence is produced by the electric arc between electrode and the base metal, mostly without pressure. The filler metal may be used depending upon the thickness of the base metal. The plasma arc welding technique, basically arc welding process. The simple metals are adjoining each other, but heat is produced from constructed arc between electrode and the job. It produces maximum temperature by using special two inert gases. These inert gases, one to form plasma and other two to shield the arc. Electron beam welding is a fusion welding process. Coalescence is produced by the heat obtained from the concentrated beam composed of high velocity electrons. Where electrons strike the metal surfaces, their kinetic energy changes to thermal energy. Laser beam welding, it is a fusion welding process. Here also coalescence is produced by the heat obtained from the application of concentrated coherent light beam impinge upon the surface of the base metals used in aerospace technology. Thermite welding is a fusion welding process. Simply is produced by heating with a super saturated liquid metal and slag resulting from the chemical reactions between metal oxide and alumina. The metal oxides usually iron oxides. Pressure is not required, but the liquid metal acts as a filler metal too. Mostly the thermite welding used in repair of railway tracks. The resistance welding is a group of welding process. Again, here it is produced by heat obtained from the resistance of the work to the flow of electric current. The workpiece is also part of the circuit. The pressure is always used because it is plastic welding process. No filler metal is needed. It is working under the principle of H is equal to I square RT. The law follows. The heat will be produced during current passed through the objectives depend upon time. The various resistance welding processes are spot welding, seam welding, butt welding, flash butt welding, and projection welding. And the importance of welding as a fabrication technique in industry as used as a tool for regular fabrication in automotive industries, automotive components, aircraft parts, refrigerators, is usually in industries as a repair and maintenance, rebuilding of worn out components. That's why welding is as a fabrication technique in industry. Application of welding used already discussed that aircraft constructions like a turbine, turbines for jet engines, ducts, fittings, components, ship buildings like shell frames, graded to shells, bulkheads, and also pressure vessels and tanks in the chemical industry, steel plates, shell constructions, joining of nozzles, various applications. So that is importance of welding and applications of welding. The mostly important terms used in welding. The beads are weld bead, weld character, fillet weld, penetration, weld puddle, weld metal, weld pass. These are the terms used in during welding processes, as in case of gas welding or in any welding techniques. So weld bead, this is the joint formed between the two base metals during welding. The appearance of the weld bead depends upon the following weld movements, that is circulating movement, zigzag movement, and straight line movement. The weld bead, the structure look like this. See after weld surface in between two base metals filled with filler metal. The weld bead, how the joint prepared and filled with the bead and the base metals. The next one is weld character. The weld character, this is the hollow space caused due to the short circuiting mechanism coupled with the magnetic arc flow. The causes weld metal to flow in the direction of the ground. By this electrode metal is filled only at the concentrated position, leaving unfilled area just before it is known as weld character. It can be observed at the end of the weld joints and even at the beginning. It causes the restart of arc generation difficult. It can be manipulated by the electrode angle by making it somewhat vertical at the point. The weld character, see this, the figure at the joint, the weld character image. The fillet weld. The fillet weld is a type of weld triangular in shape and join two surfaces at a right angle to each other. The most common types are weld in laptop joint and T-joint or corner joint. Fillet weld, see in between two base metals at a particular angle, filled with filler metal. Penetration is the depth to which the filler metal fills between two base metal pieces during welding. When there is insufficient depth of penetration of filler metal, it causes formation of unknown area. The unknown area can be eliminated by providing root distance while welding. The void in the operating path of the penetration of a pillar metal approximately 1 by 4 inch thickness of the base metal is known penetration. The penetration provides the filler metal to be easily penetrated in between two base metals and fill the joint completely. Where there is no root distance, that is no channel for penetration for filler metal under cut epios in the weld. See the actual image of penetration, that is the depth of penetration in between two base metals. Next one is a weld puddle. Puddle is nothing but molten filler metal which fills the arc. It gets solidified when the arc is removed from the puddle. The slag present in it floats or rises to the top, and these puddles stack upon one another, resulting in the formation of weld bead. Weld metal or base metal. This is the metal or two metal pieces which are to be subjected to weld to form a joint is known as weld metal. The base metal can be same time or two different metals. Depending upon the size of the base metal, only filler metal is used. Usually the base metal of this 1 by 4 inch thickness, filler metal are not used. The thickness ranging from 1 by 4 to 3 by 4 inch filler rods are used up to 3 by 16 inch of the base metals. The thickness of the filler metal and the base metals are same. The new term, that is the weld pass, one progression of welding across a joint. The resulting of a weld pass is a weld bead. The weld passes are in two types, that is the single pass and multi pass. So that is the important welding terms are you discussing now. The definitions of each and term with your figures clearly. Can you understand properly? Now we can discussing weld joints. So any two base metals, if you want to join, to fill the gap in between the joints, not only simply gap, the gap is nothing but a joint. The joint, it different shapes, you have to prepare to fill the particular joint with filler metal. That joint which will give life of the weld piece. So see how, what are the important joints used in welding processes. That is the butt joint, lap joint, corner joint, T-joint and edge joint. These are the joints are used in welding process. Not only that, it is also some edges also preferred. See first the joints, what are the different joints are used in welding processes. The butt joint, the joint between two members align approximately in the same plane. This is a very general weld joint. That means, see that figure, the two members are the same thickness and lying on the same plane. So like this image, see the figure and to observe that particular butt joint. That the two base metals are adjoining each other in between that joint to be says. So different edge joints are symbols for some butt joints. that may be straight groove in between two base metals, V groove, that is the V shape, and bevel groove, that means edge. These are the edges prepared in butt joints, usually preferred. This lap joint. The lap joint is between two overlapping members on each other. Two base metals, if you want to join, are lying on overlapping each other. So different edges and symbols for lap joints for adjoining two metals and lying one each and above. Bevel groove, J groove, and fair bevel groove. Corner joint, the corner joint between two members located at right angles to each other. This is the new manufacturing of square and rectangle shapes. See the figure? Just the corner joints prepared like this, two base metals. At two corner points are this. Actually, these symbols for the corner joint, bevel groove, J groove, and square groove, usually preferred in case of corner joints. This is the T joint, a joint between two members located approximately at right angles to each other in the form of a T. This is used in fabrication of typical shapes. The typical shapes means like this figure show this, the two base metals are lying in center of the one piece on each other. The shapes or difference are used in case of T joint, J groove, flare bevel, and bevel groove. These are the different edges are prepared in a T joint. And finally, to see this edge joint, a joint between the edges of two or more parallel or a nearly parallel member or to form edge. This joint is comparatively difficult weld joint, and especially in a roof manufacturing. Edge joints are the figure and two base metals lying like this. See figure. These are the shapes used in edge, bevel groove, square groove, and U groove. These shapes, these grooves, this is nothing but these edges is filled with filler metals during welding process. That is the edge joints. This, the topics are covered in this lesson.